Hey, this is going to be a quick tutorial on how you can color match poorly shot or just really strongly balanced original source footage with a piece of CG or a screen insert that has no color imbalance at all. Really simple to do. We're going to use division and multiplication, so if you're up for it, let's take a look. The footage I'm working with is Blackmagic Raw from a Sony FX3. So the first thing I need to do is get this footage into linear. Because I'm not working color managed, the way I'll do that is with the CST node. So it's just space, color space transform. And the color space transform node is going to be set so that we're going from S-gamut 3 cine, S-log3, that's how the material is shot. But we want to go to linear. The best way to do this is actually leave the primary alone, so we're not applying an extra color matrix to it. And we change the output gamma to linear. We turn off the tone mapping. And now this is perfectly set up to work in composite and linear and do our division and multiplication step, which is how we can actually match our non-imbalanced color really, really easily. The last step of the process, before this goes back out to media out, I might as well go ahead and do that. I'm going to hit Command-C, Command-V, pull this down here to the bottom. You hit the swap button, which just inverts what we had just done. So we're going from linear back to log. So when you go back to the edit page, color page, the colors has everything still to work with. So in other words, this media in matches our media out. They haven't changed at all. We've got this nice space to work. Now our footage, our insert here, has no color cast at all. It's just, in fact, it's this resolve screen that is gray. We need to get this also into this working space we have here of S-gamut 3 cine linear. The way I'll do that is just take this to start, Command-C, paste it after my screen insert, Command-V. Now that this is loaded into viewer, it looks totally wrong. One, because we haven't set up our viewing LUT, but also that's not the correct input space for that piece of footage. It's sRGB. So you just say, if it was sRGB graphics, just come over here, start typing sRGB. Input gamma is also sRGB. And then we'll change the, well, basically all of that is good to go. Our output is S-gamut 3 cine linear, but we do, because of sRGB, I found that it seems to work best if you turn on apply inverse OOTF. I think it has something to do with the way sRGB is calculated in here. That's what I'll do for that. And then as far as actually putting these two together, I've already resized this plate to match and did just a simple corner pin on this frame. This is not about tracking. I've got all kinds of tutorials on doing that. This is just A over B. You can see these don't match. They also look completely wrong because it's linear, and we're never meant to view linear footage on these viewers. So thankfully, there's a solution for it. It's called the viewer LUT, and that is turned on in the upper right corner of the Fusion page. But it's maybe not set up correctly for especially our situation here where we have S-gamut 3 cine linear. What we need to do is turn on our color space transform viewer LUT, go to edit, and then what you want to do is take the input color space from your output from over here. So our output was S-gamut 3 cine linear. That is our input for the viewer. And then we go to whatever you want it to be here to view things properly. It could be Rec 709 or sRGB for some monitors, but go ahead and do turn on the tone mapping, and then you'll be able to see things properly. Because without it, you'll see this is really difficult to look at. This is a little better. Tone mapping is not super ideal here, but you get the idea. Now, everything is set up for us to work in linear with two different color spaces so that we can do division and multiplication. So the premise of this is we could either color correct this footage here to match the plate, or better yet, it's better just to remove all the color cast completely from the source footage and then reapply it after everything's been put together. So there's a few ways to do that. The easiest way is just a channel booleans division and a channel booleans multiply. So what I'm going to do is first add a channel booleans. Let's see, that's the one you're going to want is this one here with the S on it. And you want to set the operation to be set to divide to actually sort of extract the color imbalance. And we want the alpha to do nothing. So that's basically it. Divide and do nothing to the alpha. It's going to take the input of it is just going to be the main footage. Okay. And then the foreground of it is going to be the like a color sample of something that should be neutral in the plate. This is going to be kind of our way of sort of just easily white balancing the footage without using a grade node, and I will talk about that towards the end of the tutorial here. So I'm going to grab a background node to sample an area in the frame here that should be white or neutral. So with the background node selected, there's a color picker over here. If I just click and drag this across to an area that should be neutral, like this Starbucks cup, that's going to select a color. In fact, if I load it, this is basically the linear color imbalance of this shot. So what we need to do with the channel booleans here, with it set to division, is let's see, this is our original. We're going to take this, feed this into our channel booleans, and we're going to divide by that color imbalance. And you can see, yes, it looks like there's clipping values, but it's not because it's 32-bit float. We've just removed that color cast. So that was before, that is after. And now we do all our compositing sort of in this color cast removed version of the footage. And then we'll just reapply this at the end of the flow. So the way that'll work is rather than sending the original footage to do A over B, I'm going to take this one that sort of had the color cast removed as this A over B in the composite here. And then I can do things like add the exact plate reflections back onto here and then invert it at the end. So let's just do that real briefly. I've shown this in my recent tutorial where I talked about how you can use find a point for screen comps. But basically, I'll use a merge node with the alpha gain down to 0 to add the original reflections back on top. So I'm doing that, taking the output of this color fixed version into the merge 2 down here. But the alpha gain is going to be cranked down to 0, but I only want it to exist in the screen replaced area. If I take a look at this corner pin output, actually, if I hit A for alpha, I've got an alpha for that, so that's great. So what I'm going to do in this node here is just restrict the added reflections to just that section. Now this is close to be ready to be output, but we want to reapply this original color cast. See how we've got this big color cast here? So the way we'll do that is a channel boolean set to multiply. After this merge 2, I'll just shift space, and then we'll do another booleans, one with the S. And this one is going to be set to, instead of doing divide, I had that set as subtract. This one's going to be set to multiply, which multiply is linear gain. It's the same as if you went and did the Cullen-Kelly trick on the color page where you change the node to linear and you used, it's the same thing. It's just basically we've defined what our color imbalance is with this background node over here. And so since we've divided by that, we actually want to multiply by that same color back into the stream. And now I basically reapplied that color cast to everything. So to see like a before and after, we could just take a look at this node right here. See the colors? See the colors? And the best part about it is everything integrates, and because we've added the light of the original screen back on here, it's actually taking care of lifting the black levels for us really easily as well. So if you jump over to the color page, because we've inverted it, it's looking in log, I can grade this all as one cohesive screen insert because effectively the colors in that whole world sort of match. I'll point out one other tool rather than just doing it this way is there's on Reactor, I'm a big fan of Reactor, there's a tool that's called the grade fuse. The grade fuse is awesome because of one feature that it has that doesn't exist in the normal color gain tool that's in Fusion or the color correct tool. It's basically, it has a reverse function to it. So like if I needed to do some sort of a color grade, or I've shown this before how you can manually sample an area and use the gain that's in here to do some sort of crazy adjustment like this. Well, if you did it the same method here, you could take this, Command C, Command V after it, and on the second one you can just say, okay, I want to reverse that correction and do all your work in between this here. So this gives you more options besides just multiply if you wanted to reverse everything. But without that, brightness and contrast has a reverse button, and I really think this technique, it works really, really nice where you just say divide by whatever the color cast was by sampling something that should have been neutral, do all your work, and then at the end of your stream here, while you're still in linear, multiply by that same value and everything should just match. Thank you so much for watching. My name is Chadwick. I'm a DaVinci Resolve Master Trainer. I'm a finishing artist here in New York. And because there is so much more to learn, I'll see you in the next video.